All right, so there was one topic from part 5 that I actually left off on purpose, and I'm going to go ahead and do part 6 and 7 together. So the one piece from part 5, part 6, part 7 that are all together, first thing I'm going to talk about is our sampling distributions. We had a ton of different sampling distributions that we ended up having. So if we took a bunch of samples, where are they going to come from? So in part 5, we actually dealt with, well, if I'm taking a sample, what's the chance that what are the sampling distributions for the number of people who might have a particular trait or who might feel a certain way? So if we're dealing with a number, well, our only option was that X, well, there was two. X could follow a binomial, right? That's the true thing whenever you're counting up a number of successes with N trials, P probability of success. And if we had a large enough sample, well, then we could also use an approximate normal with the mean and the standard deviation given on our formula sheet under binomial. So this is only true if NP and NQ are greater than or equal to 10. So that's Numberland. That was part 5, right? The normal approximation to the binomial, technically. Now, we talk about a proportion, which is what we start doing all of our work with in part 6, right? Then we're talking about a p-hat, our sample proportion. It has to come from an approximate normal. As long as our rule of thumb is met, we have independence, SRS, and less than 10% of the population, all those good things. In that case, centered P, standard deviations, PQ over N. Remember, all of these values that I'm giving you inside of these, they're on your formula sheet. So this is on your formula sheet under sampling distribution of a sample proportion. The last one is in part 7. We start talking about our mean, our sample mean. If I take a mean from a sample, what distribution does it come from? And there we had two options as well. It could either come from an approximate normal, centered at the real mean, with the standard deviation divided by the square root of n, or it could be centered at, it could be a normal distribution, same mean and standard deviation. And remember, this we had if it said normal somewhere in the problem, and here we had if it didn't said something like skewed or non-normal, letting us know we didn't truly have normality. So those were our 3 different options. I'll probably do something if this question's on the exam similar to what I did for you guys on the exam 3, which is that I will give you this on the actual question. So you sort of realize what we're looking to do. What is it that we're actually talking about? Is it the X for a number, the p-hat for a proportion, or the X bar for a mean? Which distribution are we in? Binomial, approximate normal, normal. And then what are our 2 parameters for that distribution? So that's our sampling distribution stuff. Like before, we also still have our assumptions. When we're dealing with a single variable, those assumptions were SRS, independence, and less than 10% of the population. And then our rule of thumb. And that rule of thumb is NP and Q greater than or equal to 10, NP hat and Q hat greater than or equal to 10, NP not and Q not greater than or equal to 10, depending on what type of thing we're doing for proportion. Or for a mean, remember our N needed to be greater than 30 for the Z methods, which we'll never do again. So really greater than 40 or originally looking fairly symmetric. So those were our assumptions. After that, we did confidence intervals, sample size, and hypothesis testing. And for each of these, I can break this down a ton, right? For our confidence intervals, you could create them on the test. You could also interpret them. And you could find our point estimate and our margin of error, right, from a given one. All sorts of stuff I could ask you. Sample size, mostly a calculate question, but I could also ask you if I increase my confidence level, what's going to happen to my sample size. And hypothesis tests, make sure that you're able to do all the different pieces of a hypothesis test. I haven't decided yet whether I'll give you one with the 5 steps to actually do, or if I'll just give you a bunch of questions, sort of like, okay, if this is our hypothesis, what's our test statistic? Okay, if this is our test statistic, what's our p-value? I might just break it up like that to make things a little bit easier on people in terms of doing each of the steps. So know how to do each of the steps individually, especially if you've gotten used to the calculator. I do have some example questions up for this, and I'll probably bring those with me to class on Tuesday because I think that's going to be the hardest part. And then with hypothesis testing, we also had errors and duality, right? How do the hypothesis test and confidence intervals go together? So this is all exam 3. So I'll try to get oh God, I have to do so many things. Try to get a solutions up for exam 3 so you guys can go through and check that out and make sure that you understand everything that went on. Because this to me is the most important stuff for the final, because once we get to part 8, we're doing the same thing again. So that was part 6 and 7. I got one left, which is what happened after that.